All right, back at it. Let's see. Oh, so only a Part 145 prop repair station can perform major alterations and repairs to props. I think these are some of the Q&A questions that'll help you out. So wash props. Wash the prop with fresh water after salt spray exposure. Wash prop with fresh water after salt spray exposure. That's if you're buzzing people on the beach or happen to have a seaplane. Wash with mild soap and water before inspection. I don't want to get too crazy here with my notes, which I did when I wrote them. So sometimes I spend longer trying to figure out what not to say rather than just saying it. Oh, I should have said that. So minor surface damage, minor surface. All right, so what is common with propellers is the leading edge of them, it gets pitted, you know, from bugs and all kind of rain and little tiny rocks and stuff like that. So it's actually considered rather normal and routine maintenance for A&Ps to actually take a small file and redress the entire leading edge, which is the file, the whole leading edge. You have to be careful not to change the profile, but you're allowed to do that. And then take some sandpaper and polish it and then repaint it. Funny thing, you'll see a lot of airplanes out there that have really beautifully polished propellers. And a couple of years ago, it just seemed like that was the big thing. The FAA was coming after everybody who had a polished prop. Apparently, there's only one propeller in existence, and I don't know which one that is, that actually has in its repair manual that you can polish it. All other repair manuals clearly state and paint the propeller after the repair. So you have to have them painted. Then you're not supposed to have them polished. So just keep that in mind. Repair minor surface damage, repair with the fine cut file. Let me see, repair with a fine cut file, and double aught sandpaper or crocus cloth. Double aught sandpaper or crocus cloth.
What's a crocus cloth?
I knew somebody was going to ask that. It's like sandpaper. What's the difference between sandpaper and crocus cloth? I don't. It's got to do with the abrasives that they use on it. And offhand, I don't remember what it is. Just use some sandpaper. What's that?
Sorry, Kev. I was going to say, how do you spell crocus cloth?
Crocus, C-R-O-C-U-S.
Thank you. I thought you said Irocus. So I was like, what?
No, crocus. C-R-O-C-U-S. Crocus. Or I guess I could have been R there, crocus. Okay, leading and not to as much of an extent, but trailing edges. Edges often need to be dressed. Need to be dressed. That's what you call it. When you take a file and you go down the entire length of the blade and pull out those microscopic little imperfections in there, because those little microscopic imperfections, that's where your stress risers start. And that's where you're going to get a crack in your propeller.
Dress with the crocus cloth?
Yep. Well, I take a file and go down the entire, I think I've done this to my prop even almost every annual, especially if it needs a little touch-up paint anyway. So I'll take a file and just draw it down the entire length of the prop. And I use my little jeweler's files. I don't use a giant file and take off a bunch. But but then I'll just dress it all the way down, and I'm taking out the very minor little dents and scratches and nicks that are in the prop. They're almost microscopic. You can't see them. But if you take your fingernail and run it across there, you can feel that it's not real smooth. And so then I'll smooth it all out and then do a sand, and then I'll paint it. No repairs. So let me see. MJ says, so filing and redressing is not major alteration repair? No, it's definitely not an alteration, and it's not a major repair. It's minor. So no repairs are allowed in the shank. Repairs are allowed in the shank. In the shank of adjustable prop blades. I'm not sure how I feel about this statement, but transverse cracks, which is across the blade, are usually cause for rejection. All right, outside of composite blades, I don't know of any cracks that aren't cause for rejections. They are. You have a cracked blade, I'm sorry, that thing's coming off. And I think there's some Q&As about this prop bolt holes. They can be repaired according to AC 4313, which again is acceptable methods, practices, and techniques. So prop bolt holes can be repaired. So may be repaired by bushing the holes, may be repaired by bushing the holes. And sadly, if that's happening, it's usually on account of bad maintenance. Let me see, may be repaired by bushing the holes. Let's finish this off. So, or using 1/16 inch larger bolts. And then this last statement is bolt hole repairs to wood props are not allowed. So bolt hole repairs to wood props is not allowed. Okay, I'm gonna tell you right now, I'm not doing any of this. Hey, no way, no how. So when I think this through, all right, so if I've had a propeller that somehow has damaged bolt holes where the prop mounts to the flange, and either the bushings from the flange go into the prop, or it's just prop bolts in general. And I think, okay, well, AC 4313 says if those holes are bad, then I can just drill out the prop, bush the holes. No way am I doing that. Or two, maybe drilling the holes out a little bit bigger and using a 16th inch longer bolt. Well, that means I got to also do that to the prop, the flange of the crankshaft, and that is not approved. So I don't know. Well, it says that. I'm being really cautious about that one.
There's too much liability.
It's too much liability. I don't know. Some of this is kind of weird. You're allowed to. It's something you can send out to have done, and this is actually pretty common. Shortening blades, but it stands to reason if you shorten one blade, shorten the other, shorten the other side, and that's actually kind of a common occurrence. That is a major alteration, or that is a major repair. Might even be an alteration. And the reason why it's done is if you damage the blade, you get a bad enough rock chip, a crack happens, then rather than throw away the whole propeller, you actually shorten the blade if you're allowed to. You just got to make sure you do the other side too. Something that it's sad, and it shouldn't be this way, but it's overlooked. And as mechanics, we should be doing this all of the time. So I would say that, you know, in my shop, every time something came in for an annual, it was one of the things that we addressed and would write down as either a discrepancy, airworthy or a discrepancy. You know, we highly recommend it. And that was repainting of props. They're expensive and you want to protect them, and it's the paint that protects them. And so especially the back, or I'm sorry, the back of it, which is the face, especially the face where the flat black is, the flat black it's not a very robust paint. The front is, for whatever reason, you can buy propeller epoxy paint in a can from Tempest, I think is a brand name. They make it, and we've got it even in the tool room at school. But the back is usually just a flat black that is used. And so it's a lacquer or something. It doesn't last very long. So it's almost a good idea annually to sand down the back of the blade with a little bit of sandpaper and just give it a coat or two of black paint, and then fix anything on the prop that is missing some paint. So, but use caution. So use caution. I say paint often, but use caution when adding finish, which is either paint or varnish, to prevent an imbalance, to prevent imbalance. Yes, Stephen.
I've noticed like on a lot of props, it's not black on the back, but it's like a gray, like a metallic gray.
Well, when you say the back, you mean the face or the back?
The face. So the part facing the users, which is the face, which is the back. So
the part the pilot sees?
Yes, the face.
That's the back.
Yeah.
Face. I'm sorry. Now you got me going.
Yeah.
So yes, the part the pilot sees, which is the face.
Yeah.
It's supposed to be flat black. Flat black. It's the only approved color I'm aware of.
Oh.
Hey, Kevin.
Yeah.
When you do the face, did you have to mask the other side, or?
I do, yeah. Well,
matte black, you know.
First of all, I don't want to get flat black all over my airplane, and so I put blankets and stuff on the cowling, take off the spinner, and then yes, I do mask it off, so I don't get the flat black onto the back of the prop, which is the rounded part. Which there we go. And I kind of already said this: polish scratches with fine sandpaper, HIGKL, polish out scratches with fine sandpaper, all right, I'm going to make this one rather either very, very simple or very, very complicated. Let's see. So I have an entire page here that I'm not going to go over, but I'm going to say repair of, we'll say rock chips, damage, scratches. And so I had this entire thing here, which came out of AC 4313. Let me see. Actually, and it dealt with bent blades and all kinds of stuff with that, and what the limits are. And it got crazy. And what I did, I don't know, sometimes I think that, oh, you know, a little bit of knowledge is great, so I'll just go with it. And so I got into this slide and I explained how to use it, and where you can repair the blades, what the bend radius is if a blade got bent, and how you can fix it, and what station it could be. And I explained all how to use this. And that goes on for a page and a half. And I decided, you know what? I'm not going to do that anymore because it's ridiculous. If you have a bent blade, my gosh, don't be trying to straighten it. All right. That's something a repair station should be doing. And so I'm not going to do that.
And I'm assuming if you work at one of those repair stations, they're going to train you how to do it.
Okay, first of all, they're going to train you how to do it. Secondly, I'm going to bet you probably a large lunch at a drive-through, supersize included, that they're not using AC 4313 to do any of this. They are using the actual repair station, the repair manuals from the manufacturer. And so I'm just going to say this, you know, use correct manual, use correct manual. Actually, it's repair. I shouldn't even say rock chips. It was all about bending and all kinds of stuff. But I will say rock chips is something we do as mechanics. So repair rock chips, use the correct manual. Some manuals have one thing, some have another. In my notes, I wrote, what did I put? Something about, oh, I hate to do it, because I just wrote a quick note, and sometimes I repair dimensions instead, where you were, I'm not going to do it too much, but you have a blade, and then you have a, sorry, that should be nice right there. And you have a rock chip. And of course, this is magnified 100,000 times. And you guys are going to do this, and you're going to find out what you have to do is you're going to measure the width of this, measure the width of that. And then based upon that width, the depth, so the depth, width and depth. So you're going to do depth. So based upon the depth, that's what I should have said, you're going to figure out the ratio of the repair. And there's an actual ratio of repair that's going to tell you when it's done, it has to be like that. And the reason why it is like that is because you can't take a propeller blade that has had a piece of damage like that and say, okay, we know that we don't want a stress riser, and we know that everything has to be nice and smooth. Therefore, you smooth it out and it looks like this, right? That's just, yes, you have smoothed it out, but if you're using if you know what a chainsaw file is, and you just actually just saw down in there like it's a hole, that's not really relieving the stress cracks. It's actually it's concentrating it back in a little bit wider area, granted, but that is so much different than a repair that is done out here like that. And it actually gradually lets the stress transfer through, and then you're not going to develop a crack. So I believe the ratio is 1 to 10, but I'm gonna let you guys look that up when we get there, because it's on the prop that you're doing, because it's different for every propeller manufacturer. So I'm gonna let that one go. Actually, let me, I was thinking we could look up. Let's see. What book do I have? Here we go. Just out of curiosity, we call it 4313. Always good to teach on the fly like this, right? Corrosion, bolts, nuts. There we go, exhaust, hydraulic. Repair metal props is 8-29. 25, 67, 28, 29, let me see. Most everything I've got for you has actually come out of 4313. And I want to say 4313, my memory is they actually don't give you a ratio right here. And I think that ratio comes out of the Sensenich book is where we get it. And I'm in my memory, and I'm almost right, and I'm here looking at 4313, is it doesn't actually give you anything about that. Almost leaves it up to you to be use your best judgment. So let me see. Yeah, it's mostly about bending them back. I'm like, I'm not gonna bend them back. And then it just gives you some pictures of what you're gonna be doing without real definitions in there, which I don't like that. So I believe, have you in class use a Sensenich manual, and that's what I go with on that one. So that's why I say use the manual. So, and make sure that you dress them out in a nice wide area like that. So maybe I'll look that up and get back to you at lunch or something. Okay, so moving along, let's see, that's gonna put me LMN. Well, I got all kinds of stuff. Oops, I'm missing a page, that's why. There we go. Okay, so that brings us up to like 3 pages of maintenance. Let me see, let's shorten this up a little bit and see what we can do here. So we'll make this 20, maintenance. We've talked a lot about maintenance. So I'm just going to hit some highlights. You guys are going to cover a lot of this stuff, maintenance and inspections when you get into second year. So I don't want to drag this out. Let me see. So let's see if there's anything I need to write here. Maintenance, check aircraft records for replacement or modification of the tack and change the propeller model, engine model, installation changes. Nah. This is all about inspections that you're going to get in second year. I'm just going to write some things. Don't trust tack gauges, tacks. I don't trust the tachometers. They're almost always liars. And so I always check tachometers on annual inspections with a handheld tack checker that I've calibrated, and you'd be surprised how bad tachometers can be. So if you're doing that static run up and you come up with a problem, my first assumption is the gauge is bad. Almost with everything with aircraft, my first assumption is always, I don't trust that gauge. We talked a lot about maintenance of wood props, and I told you how temperamental they are and to be careful with them. Although they're not real expensive, the same things are, if you were asked on an oral practical exam to inspect a wood prop, always make sure you've got the standard things. Check for cracks, leaks. Where's a wood prop leak? I don't know. Let me see.
Leaks out all the moisture, you let it accumulate.
That's right. Talked about varnishing them, make sure the varnish is put on evenly. The face should be flat black. We talked about that. Talked about flicker vertigo. I talked about checking the torque on wood props a lot. Yeah, here it is. The torque for the bolts on that was 140 inch-pounds. Not very much.
You said those had a castellated nut with a cotter pin?
They sure do. 23, let me see.
So then you have a torque range. What would your torque range be?
I don't remember what it was exactly.
Kevin, I have a question on a synthetic prop. How, like the MTI, where it's the German ash wood on the inside.
Yep.
How would you like dress the edge on that? Would you also because it's like fiberglass?
Don't be. It's not about metal props.
Yeah.
Dressing metal props. Don't be dressing wood props and stuff. That's bad. Let's see. Yeah, I just kind of go into great detail on maintenance. Inspect for cracks, chips, dents with a 4 power magnifying glass. Dress out all chips, nicks, gouges. This is just redundant stuff here. Polish the fine sandpaper. Follow manufacturer's recommendations. Repaint when missing. I think we got it. I'm not going to talk much about balance. In fact, I'm going to actually, I normally do, but Larry, I believe it's Larry Johnson, he covers prop balancing in pretty great detail. In fact, we're pretty fortunate that I believe we just bought a brand new prop balancer, a dynamic balancer. So there's a difference between static and dynamic balancing. Static balancing is not that. Static, nope, go back.
Ooh, I saw that wrecked airplane.
Yeah. Okay. Static balancing is when you take a prop off and you put it on a balancer. And we actually have one of these in the shop, in the NDT lab. I took it and moved it so I could put our new Magnaflux in there, but it's back now. And what you do is you put your prop on to these arbors and you put it on a balancing machine that is perfectly level, and you do a vertical check and a balance and a horizontal. So the vertical check, if it stays vertical, it's vertically balanced. If it's horizontal, you put it horizontal. If it's perfectly horizontal, it stays horizontal. So a prop that is out of vertical balance will not stay vertical, and a prop that is out of horizontal will not stay horizontal. You can write that down. I'm not going to. And what that means, so if I put it right here, this one's more obvious. If this blade is heavier, this blade's going to roll down because it's free to roll. You're going to say, well, that blade's heavier, so you have to add some weight to this blade. And how you add weight to blades depends on what kind of prop it is. Wood props, they can actually add some solder to some of the metal tipping. On some props, you can actually have little spots where, and I'll show you a little bit later, where you can put lead wool inside of hollow bolts. They're hollow on purpose for that very reason. Some of them, they have little attach points on the hub, little screw holes where you can put a little plate. Some of them you can add washers. Vertical balance is a little bit more difficult to comprehend. It's like, well, why would it be out of vertical balance? And the reason why it's out of vertical balance really has more to do with the hub. So if the hub was heavier on this side, it will, near the axle or the arbor, it'll stay this way forever because it's weighted down here and it's very happy there. But if it's heavier right here, it's always going to roll down. So that usually means that your hub is out of balance or something closer to here. So, and of course, you have to also balance 3 blades in the same way. But this is static balance. And then the new thing, well, first of all, you want it to be statically balanced. Then you put it on the aircraft and you run the aircraft and you do a dynamic balance. And a dynamic balance, you use a accelerometer bolted to the engine and a strobe light, which picks up the blade. So this always knows which blade is doing what at all times. And this accelerometer measures how many inches per second, IPS, of out of balance you have, how far the airplane is moving in inches per second. And then, so what it'll do, and you put a little piece of tape, reflective tape, like on this blade. And so there's an eye that sees it and identifies this blade. And then you'll run it and it'll say, well, you need to add X number of ounces to your spinner bulkhead or something. And then you add a few washers or a screw or something and then run it again. And so that's dynamic balance. And that's what I'm talking about, that a prop that is statically balanced like this, you should be able to reinstall it any which way and it won't matter. But an aircraft that has a dynamic balance, then that is set to the engine and you always have to make sure you put it back on exactly the right way with the number 1 blade facing the way it was balanced and stuff. So you can't throw it out of balance. So that's that. Let's see. Oh, just, common problems. This is clearly cause for rejection. I think this is the same blade over. This is just pathetic here. What I'm seeing is really nice paint, but nothing in the middle. Here we have the face, and this is what usually aircraft blades look like, is you go to the face and it's like, well, it was flat black at one point, but you have all of this not painted. So not only is that bad for the pilot as far as flicker vertigo goes, but it's also terrible for the prop because it's going to start corroding. And they're hard to find. It's not even a price thing anymore, but props are stupid expensive. No. All right. Let me think. Is that about it for this section? There we go. Let me see. Covered balance, horizontal balance, dynamic balance. Yeah, there we go. I think we're good. Cut out some of the fluff. All right. How about, let's see. This look familiar to anybody?
Who put it through the cheese grater?
All right. One of my favorite things. So let me make sure we're good to go. Let me see. Share my computer sound. Next one. Just load up.
That our runaway plane doesn't run away. Joe Rakow is an aerospace specialist who studied the aftermath of thousands of air disasters. Now he's helping calm.
I'm sorry, you guys know what's happening, right? I forget. So.
No idea.
Okay. You know Mythbusters, right? Everybody's familiar with Mythbusters?
Yeah.
Well, if you're not, I'm sorry for you. Greatest show probably ever, except for Top Gear. Okay, so what Mythbusters did is somebody sent them in this picture. And what is said is this was done by another aircraft running alongside of it. And so these are the propeller marks as it went through there. And then it finally came to rest here. So the myth is, did that really happen? And this clip that I found online years ago, it starts right here kind of in a bad spot, but it's the final test. So if you're not familiar with Mythbusters, I guess you can let me know in the chat thing. I'm interested that, of your sheltered life. So Mythbusters are going to prove or disprove that this happened from a running airplane hitting it, if it was real. So that's what they're doing.
That our runaway plane doesn't run away. Joe Rakow is an aerospace specialist who studied the aftermath of thousands of air disasters. Now he's helping cause one.
What we're looking at after impact is that the entire mass could slide as far as 20 feet, and also pieces of the fuselage or pieces of the propeller could, in theory, fly on the order of miles given the energy that they have at impact.
That's a pretty sound argument for being a long way away.
That's it.
A bunker is erected on the other side of the dry dock.
Oh, it moves nice now.
We're nearing departure. Propeller and plane are lined up.
Given what I'm seeing, we want to line this flat panel up exactly in line with the side of that cart, and we'll be at the perfect relationship.
Okay, we're done. Let's anchor this puppy.
Time for a pilot run.
We want to make sure all these systems work before doing the final test, because we only have one shot at this. That means everything has to be going as good as we can make it go so that that test is as accurate as possible.
For the rehearsal, they're going to keep the engine on a long leash, just in case. But it doesn't look like making a getaway.
There seems to be a short in the kill switch circuit. Over.
Can anybody identify that engine? Super students.
It was a 6-cylinder turbocharged. Was it a TIO 540?
Damn, good for you, man. TIO 540. It's a Lycoming, just painted the wrong color.
I understand.
So now, you got it?
Yeah.
Okay.
That seems good.
Okay, cool.
The engine starts taxiing, reaching a dizzying 9 miles per hour. Hope it has more grunt than that, or this flight will be canceled.
More power. Yeah, I think it does.
Remember, they're aiming for around 30 miles per hour.
Do you want Grant to kill the engine?
Yeah, go ahead and kill the engine. Let's see if it does it. Copy, killing the engine.
Hey! That worked beautifully. This engine is leaking at every possible seal, internally and externally. Whether or not this was the last thing we're going to do to it, it's the last thing we're going to do to it.
Captain Earl and co-pilot Brian goose up the throttle. This time, a runaway success.
Man, it was tugging at the reins. It was trying to be let loose. It was beautiful to see. I have no doubt that once we release this thing, it's going to be like a freight train, very much like a freight train, and that it's going to work.
It's crunch time.
That it's going to work.
Oh. Wastegate. Turbo inlet.
It's like a freight train, and that it's going to work.
It's crunch time. Literally.
Everyone takes cover.
That is a monster of an engine.
Ladies and gentlemen, welcome aboard Mythbusters Flight 101 to Shred City.
Oh my God.
Please fasten your seatbelts and prepare for takeoff.
Come on, baby. Come on, stay there. Keep going. Come on.
True.
Contact. I'm awaiting an all clear.
Now that is a shredded plane. The engine performed perfectly. The high-speed camera shows the prop blade slicing through the fuselage as though it was made of cardboard. Trust me, you wouldn't want a window seat.
That's exactly the slice pattern we see in the picture. I mean, it's a little bit different, but we see that the airplane. It's a little bit excited. I'm so excited, man! It's exactly what we see in the picture. It's vertical slices from the blade. That's just, I'm stunned.
I think we lined it up pretty good.
Dude, give me some skin. Damn!
Perfectly. Takeoff. City.
Oh my God.
Please fasten your seatbelts and prepare for takeoff.
Come on, baby.
I was trying to identify that ship right there.
I think NJ wants to do this. That's cool.
Yeah, we should just try it.
Yeah, they're out.
No, we have like, you know, fuselages laying around.
I know. Remember, this is supposed to be at the end of the week, end of the day, but it's not.
What?
It could be.
Could be. Chicken butt. Oh.
See, it's like, guess what? Chicken butt. I don't know. I guess I was in a good mood that day when I made my PowerPoint. So. All right. Having said that, time for review.